Hello, fifth grade mathematical thinkers. On with geometry. We are on lesson 5.5 and its title is Isometry Transformations. So our learning target, I will be able to perform transformations with geometric figures, and I will be able to classify a rotation by the number of degrees that are needed to produce an image. So there's a lot of new vocabulary for this unit or this particular lesson, and you'll see some of the definitions right here. You may want to stop the video and record some of the information to help you remember. So first of all, transformation comes from the word transform, and a transformation produces another figure. Now, the title of the lesson is Isometry Transformation. So we're going to produce another figure, and the part of the uh, term or vocabulary isometry comes from a Greek word that means same measure. So when we produce a transformation, we're going to produce another figure that's going to look like the first figure. There are three types of transformations that we'll be looking at. And earlier, probably in third grade, you had different names for them, but we're going to use the mathematical terms now. So the three types of transformation we'll be talking about are translation, which is a slide. The shape simply moves up, down, left, right. A reflection, which is a flip over a line of reflection. So something can flip along a horizontal line, along a vertical line, or on a diagonal. And then rotation, which is a turn. And objects rotate around a point, and they can rotate in the direction that the clock hands move, which are called clockwise, or in the opposite direction, which are called counterclockwise. And you'll see examples of these. Now, when we transform or produce a transformation, we start with a pre-image. The pre-image is your original figure, what you start with. And then you create an image. An image is a new figure, but it has the same size and shape as the original. So it's symmetrical in that sense. It has the same shape and the same size. It simply is turned or flipped in a different direction. So again, you might want to stop the video, record these words and their definitions because you'll need to know those. So here are examples of reflection, rotation, translation. This is our line of reflection, okay, and the letter F, pre-image, is reflected over this diagonal line, and here's what the reflection looks like. So this is the image. Here is an example of a rotation with an image, pre-image, excuse me, right here, and then an image. Here's the point that the shape is transforming around. So we can have a 90-degree rotation, we can have a 180-degree rotation, a 270-degree rotation, and these would be going clockwise, the direction that the clock moves, or we can have a 90-degree, 180, 270 rotation going counterclockwise. And then the third type of transformation is a translation, which is often called a slide. The pre-image slides to become the new image. So let's look at this again in a little more explanation. So again, when we want to do a reflection, here's the line of reflection. It's a vertical line of reflection. Here's our pre-image, and we sometimes call a reflection a flip. So when we flip over the line of reflection, you see where our point A goes, flips over, point B, C, and D. Here is a rotation, and it's around point P. right there. So here's our pre-image, kind of like an envelope with a flap. Here is a 90 degrees clockwise rotation. Here is a 180-degree clockwise rotation. So you see what happened to this. It flipped, didn't actually flip it. It rotated around this point here, 90 degrees. And then we take that part of the envelope. You see it rotates again, 180 degrees, and then it rotates down 270 degrees. And this is clockwise. Now, if we take that pre-image and we go counterclockwise, here's our 90-degree counterclockwise. So we can see how that bottom of the envelope, here's the flap, has changed. Then this moves up this way for 180 degrees counterclockwise. And then this moves this way for 270 degrees counterclockwise. So again, there's always a point of rotation. We measure the degree that it's rotated, and typically it will rotate 90, 180, 270. Around that point, this would be clockwise in the direction that the hands of a clock move, and this would be counterclockwise. And this is an example of a translation, and the translation slides our figure, and it can slide it to the right, it could slide it up, could slide it down if we had a 4-quadrant grid. And you'll notice in a translation, these are shapes that are labeled. So this is called MNO. And the second shape, the image, pre-image, image, you'll notice that each of the letters has a little 1, very small 1 by it, because this is the image. It's the second drawing of this shape. So if this were our pre-image and the coordinates are listed there, this would be a translation with the new coordinates listed. This is a horizontal translation, just moving this way. Here's an example of a vertical translation. So here's our original pre-image, and I can tell because there's just one letter, and then it was translated vertically. Here's my image, and I see the M with a little 1, N with a little 1, and the new coordinate points listed. And here's a diagonal translation where my pre-image is here and the slide is in this direction. So you can go back and review any of those definitions, okay, before you do these 3 activities. So the first one is name the word that will result when this figure is reflected over line AB. So here's line AB. It's a vertical line. We're going to flip or reflect this half of a word to this side, and it's going to spell a word. So you need to name the word that it spells. Then here is an example of a translation. We have triangle CAT. So you'll see they asked me to draw CAT. Point C was at point 1, 1. Let's put this down. A is at point 3, 9. And T is at point 8, 5. Now they give us the coordinates of C1, and it says that we're going to need to put a point at 4, 7. So 4, 7, I'm going to make a point. Get my pen working. There it is. And I'm calling that C with this little 1. All right, now what they're asking you to do is decide where will the coordinates for point A1 and T1 be. So you have to look at where C1 moved. Look how far over and how far up I went from my original C. So look how far I slid over, how far I slid up. And for A1, I'm going to need to be that same distance. So you're going to figure out the coordinates of where A1 and T1 will go. And my suggestion when I solved this problem, I got a piece of graph paper and I graphed CAT, then I graphed C1, and I figured out where A and T would need to be. Now they'd be off this graph. That's why you'll need a larger piece of paper to decide. So that's your second activity. And your third activity shows you a pre-image and it just asks you to identify figure A, B, or C. Which of those figures is a clockwise rotation from here 270 degrees? So clockwise, and remember, think of where it's starting, 90 degrees, 180, 270. What will it look like when it rotates? So that is the information for our lesson on isometry transformation. A lot of new vocabulary. Some of these are things that you have seen, just maybe with different names. We're going to remember the words now: reflection, rotation, translation. And you'll be doing some work in your math journal practicing this. You'll want to pause the video or go back after you see this last slide to answer questions 1, 2, and 3 on a piece of paper, and you may use graph paper. This last slide is not part of our lesson, but just an extra little challenge. How many triangles do you see in this figure? And it's multiple choice. So look at that, see if you can determine how many triangles are in this figure. Thanks for listening. Record your answers and you will be ready to work through this unit assignments.